and either join with audio or leave the meeting. Well, I'm getting audio over my cell phone, which is what I'm using for my video here.
Mhm.
Do I click join with audio so we end up with two audio feeds?
I can hear you fine, Bruce.
Now you've
You're
got an
on,
echo.
Barrett. You're on, Ronnie.
Am I on? Doggone it, we're all on. The old guys getting together on the screen. Everybody, hello and welcome. On behalf of the Santa Barbara, California Longtime Telescope and Astrophysics Club, it's the Santa Barbara Astronomical Unit's hourly, weekly, 1 hour weekly gathering on screen via Zoom of the SBAU Astro Hour. It's number 183 into our fourth year of broadcasting, if that's what this is called. It'll be for August 26th, Monday morning through September 1st, Sunday. My name is Ronnie Heron, your host, and we'll meet the Brain Trust on screen with me in a moment. Our club's based up at Santa Barbara's beautiful Museum of Natural History in Mission Canyon. Our next First Friday general meeting, a week from this Friday, 2 weeks away, September 6th, when Dr. Maciero will come to town, address us on those nasty asteroids just might be looking for us using infrared. You're also invited to our SBAU membership party. You don't have to be a member, but it's a second Saturday Star Party. Hang on, I'll introduce you to the group here. Meanwhile, watch us online on YouTube. And here's what we're going to talk about. The Wolf-Rayet star, WR134. A little tension involving Edwin Hubble's cosmic constant these days. James Webb threw some sort of, I guess, a tool into it. Europe's juice probe. Can't read my own writings. They're sending up juice and we're running out of acronym names. On the way to Jupiter, NASA's Europa Clipper is going to follow. We're going to look into the moon of Jupiter that has an ocean on it called Europa. Ever heard of the Headphone Nebula? We're going to learn about it. There's also a lizard out there and a trip back in time this week about the years, and using Roman numerals, we're going to find out why there's no year zero. We also got our silly cartoons around the corner. Let's meet Jerry. He's back and healed. And how are you, Mr. President? Jerry Wilson?
I'm fine. Good morning.
Okay, you're going to be with us for Friday's meeting. That's you got 2 more weeks to heal.
Yeah.
You weren't really what's the word for it? Flat on your back. You didn't even know you had that damn COVID, right? When you got back?
Yeah, well, it was a day or two later after we got back that we tested positive. We didn't
Okay.
do good.
Maybe they're a little behind times over there. Do you enjoy Ireland more than UK?
Oh, yeah, immensely. Felt like going home, actually. They have the same silly culture, verbal culture with each other that my family does.
Yeah.
Is that right?
Yeah.
Well, you look Irish in your own, your background, right? Is Irish?
Yeah. County
Okay.
Longford.
All right. He's been our beloved president for 5 or 6, 7 years. I'm right behind him by a couple of years. I replaced a 17-year-old. That's a long story. Here's our outreach coordinator, an incredible guy, Chuck McPartland, on screen, pulling for the Ukrainians with the flag behind him. He's married to our incredible merchandise manager, also holding on job of treasurer Pat McPartland. And he'll tell us briefly, if I remember to throw it to him, some of the things that are coming up around the corner. Tom Whittemore, married to Maureen, edits our newsletter. In fact, it's on its way to, I guess, our inboxes right now, Tom.
No, I sent Chuck the wrong issue yesterday. So Chuck just got the correct issue this morning. Okay.
Well, that's what I'm asking about. Did the rest of us get it too?
Well, it goes through Chuck. Don't forget, it goes through Chuck.
I didn't know that.
I converted to PDF so that it's smaller and easier to email and so that everybody can read it.
Yeah.
Right.
He also adds moon phases on the calendar. He does a lot of
Provided we can read, yeah.
What's your article on the newsletter about, Mr. President? Just curious.
Oh, it's very quickly about Burr Castle and the giant telescope that's there, the 6-foot diameter telescope.
And also about your Irish background, Jerry.
1845, yeah, and me.
So we do get a follow-up story about your trip. Son of a gun, also joining us is Bruce Murdoch, longtime supporter, telescope enthusiast, and also an organ guy. That doesn't mean he's an organ donor. I'm sure he is one, but he runs the Santa Barbara Theater Organ Society and really is part of us. How's Bonnie doing?
She's healing. She's in a lot of pain.
Oh,
Well, broken bones when you have osteoporosis.
Is she being wheeled around your house in a you know what kind of chair?
Well, she has a wheelchair her mother had.
Oh, all right. Well, it's
She
going to
replaced
happen to
that.
all of us, so keep that chair handy.
Well, I
I'll
asked
probably,
her, surgeon, a guy named Eric Shepard, uh, is osteopenia more prone in women than in men? And he says, oh, yes. Oh, yes.
is that right?
Well, they have different hormones than we do.
Oh, no kidding. Thank God. Incidentally, I forgot to identify Tom Whittemore's wife, Maureen,
Hmm.
and she misses working at the anticoagulation clinic, doesn't she? She's retired, and you're retired from Westmont. And a very busy man on screen with us, Tim Crawford,
Howdy, howdy.
lens and telescope expert and the star of the Tuesday. I know Jerry's going to be on the workshop tomorrow night. Are you going to be on board?
Oh yeah. Oh yeah.
Always
I
there.
answered your email, Tim. Did you get that?
I did. Thank you, Bruce. That was really nice information.
Could a person watch that show long enough and learn how to grind and polish their own lens, you think, or mirror?
No, you have to. No, it would be more likely that you could do that if you got the guys in a workshop to start you off, and and especially if you're in the area, they usually come by and visit you and show you a couple of little tricks. And we have a guy named Chuck Watson in our group, and Jerry Wilson was really kind enough to go over and show him a lot how to.
But we're long over meeting in that little house where we had the potluck in June. We don't
Right.
meet.
Right.
Yeah.
That's
Never.
kind of an honor. My
We
mentor,
have,
Whittemore,
we have
over
too many people in the workshop that are out of the area that couldn't get to the museum every Tuesday.
right.
Plus
And
those
Tom
dead
Whittemore,
dinosaurs.
I wanted to mention that Tom Whittemore is the guy that is my mentor. He's the guy that taught me how to do everything. So he's right here.
Yeah.
All
Yeah,
right.
Tim, I also have a heck of a lot of stuff for mirror making. If
Well,
you
we're all invited.
if
All
you
the
want to
members.
just think about that.
Let's see Jerry's forwarded silly science cartoons and a few thought provokers. This happens to be the hovering pair of aliens looking down on a typical Santa Barbara neighborhood, and there's a guy wanting another close encounter of the third kind. One alien says, wait a minute, isn't that the same guy we abducted last year? Had to return because he drove us absolutely nuts. That's Tom Totten's house. My God. Okay. Here is one of our thought provokers. Good luck. I'm an engineer. To save time, let's just assume I'm never wrong. Okay.
Well, if you take a look at the equations in the background, half of them, or more than half of them, are wrong.
I can't see.
They're just crazy.
Yeah.
Right.
Okay. Well, I don't see any of them. All I see is white.
Hmm.
Maybe there's something I've got.
Well, there's a
wrong.
nonsense,
Matrix.
matrix. Thank you. Yeah.
Mhm.
Is that what yeah, I did see that in your talking points, Jerry. Just out of curiosity, on screen, raise your hand if you were an engineer. I wasn't. Jerry was.
Sort of.
The
Sort of.
software
I
count.
was an engineering manager,
Okay.
but trained as a physicist.
And veteran of Hollister Avenue out there.
Yeah, the Goleta corridor, as it was called.
You guys like to get together. All right. This one we're going to need some explanation. How much do you overthink? Me? Is that the continuation?
This is the guy looking puzzled. They ask you to pick out every square that has traffic lights in it. So something inevitably goes over the border. So you're thinking, do I click this one as having a traffic light in it, or do I just go with this one?
I answered that email. That's they use these, the AI people use these, to train themselves. What is a traffic signal,
Right.
for example? And you don't even know it, but I read an article about that.
Yeah.
So you're saying it's about AI.
No, this resonates with me as a person, because I'm always puzzling over whether to do that or not. How much of it has to be in there to count? So I usually reject these things, and so far I get in everywhere.
Okay, so he said that there's only one traffic light, but there's actually two, or
No, Ron. The whole idea, you can't see it, at least on my display, but that picture of the traffic light is divided into a grid with squares. And as part of these checks to see if you're a robot, you know, trying to get onto a web page, they do this check to see if you're a human. And you're asked to pick which frames in there include a traffic light. And the person who's overthinking it is wondering if this tiny little bit should be included.
Oh, why is it a bit? Why is it disconnected from?
Because the grid happens to cross over there.
Yeah, which was placed randomly.
Grid. Oh, you mean to separate?
There are white lines that define a grid, a 3x3 grid.
Yeah, they're not showing on my display either, but there's a grid
Oh.
there.
We got to get to the problem of this.
Yeah.
Display's not working right.
Yeah, here's an interesting comparison of geometric shapes. We have the Gon family. Pentagons have 5 shapes, like 5 sides. Hexagons are 6. Octagons, of course, your stop signs. And polygon of cracker is definitely gone, if you notice.
Yeah.
Polygon.
Polygon.
Okay, we like that one. Here's some sunbathing on the moon. Mom's trying to get a little sun, and Junior yells, "Mom, some aliens just stole my rock collection." Yes, dear. Oh, these damn kids these days and their crazy imaginations.
That's a good one.
Those thieving astronauts. And here's a bunch of the word ship in 3 different verbs. There's
It's a tongue twister.
It says ship. All right, I'll read it. This is a shipping ships, which means that the word ship is both a verb, a noun, and an adjective.
And a gerund.
I'm trying to figure out what the picture is. Is that a real picture?
Yeah.
No.
This is a
These
real
are
ship
boats that are
down here.
probably going off to a scrapyard.
Okay, so it's got,
I think this is
Made up.
photoshopped. Yeah.
Well, they do have a ship like this because when a U.S. destroyer was attacked by a speedboat in
Yeah, the
Middle
USS
East.
Cole, but that's a much smaller ship and it's
Yes,
Dutch.
it was. It was a U.S. destroyer, but they brought it back on a ship
Yes.
that acted like a dry dock.
Yeah, that was a Dutch ship and it's
Yeah.
much smaller than this. I
Yeah.
mean, these things are hugely massive. You could never, yeah.
It is an
Impeccable.
impressive picture, but it might,
Yeah.
you might be right. It might be a Photoshop,
well, that's sort of
but it
like,
makes a good tongue twister.
Yeah.
along with how much wood could a woodchuck chuck if a woodchuck could chuck wood?
I never had trouble with that one. It was the skunk stunk and the stump and stuff like that. That one really got me.
Have you ever heard the one with the word that 4 times in a row? It's a sentence talking about another sentence that has the word that in it, which
No.
happens to be a pronoun. And so the new sentence says that sentence has is a pronoun.
Well, when I was a kid, Ron, I used to come home, from the nuns with these tongue twisters, right?
Right.
And my mom says, "Oh, those are easy. Listen to this one." And she said it in Polish.
So you don't know if she got it right.
Yeah.
Well, we used to spring a really
my mom was
dangerous
Polish.
one on the foreign students that had to do with the pheasant plucker.
Don't play with that one.
Yeah.
All right. We don't have the planets in the sky, but we've had some close encounters with Mars lately, gentlemen. You want to report in, Bruce? Or
Well, actually, I saw more Jupiter. Jupiter was nice and bright up in the west. Yeah, I guess at about the 8 o'clock position with respect to the moon. And Mars was down around the 5 o'clock position with respect to the moon, and it was much dimmer, but it was red.
we'll be talking about one of Jupiter's moons here in a minute and how they're getting it there. Mr. President, you want to launch forward? Welcome back. It's good to have you on board again, Captain.
Thank you.
All right. Blow that sucker up. Use TNT if you want. Oh, here we go.
Yeah, this is as I'm sure you're all aware, our Western culture is a direct descendant with some variations of the Roman Empire. And Rome is responsible for our calendars, the first calendars we had. And there is no year 0 in our calendar because Rome didn't have a 0. in their number system. We went directly from 1 BC to 1 AD. And this little chart here shows the number system for Roman numerals, which we learned in elementary school when I was there. I've met a lot of young people that don't know this system, so I guess they don't teach it anymore. But it's symbols, and they add the symbols. This would be hundreds place. This would be 3 C's in a row, so this would be 300. This would be 30, and to go to 400, you go to 500, which is D, and you subtract 100 from it. So a smaller number that preceded the other number is a subtraction. This is an addition. This is 200. And the number system is pretty good for counting things.
D is 5, huh? Okay.
D is 500, or
500.
V is 5.
P is 5.
Right. Okay, got it.
So yeah, here D is 500. There's no 5,000 symbol. L is 50, and V is 5. So 1900 was MCM, and LV would be 1955. So it's a neat number system. You see it carved in stone all over the place. In England, they have things they still carve in stone with those date systems on it.
Well, the courthouse in Santa Barbara has that. It was built in 1928.
Right. And so the gist of the whole thing here, the reason I was doing this was I saw a real quick blurb on this topic and made these points by Neil deGrasse Tyson on Facebook. And as we know now, the Western calendars start from year 1, not from year 0. We went from 1 BC to 1 AD, no 0. So that means that 1 decade is 10 years. The first decade is 10 years from 1 to 10. The next decade is from 11 to 20, etc. 1 century, the first century, is from year 1 to 100. The second century is from year 101 to 200. And similarly, 1 millennium is from 1 to 1000. The second millennium is 1001 to 2000. And the third millennium was 2001 to 3000. And this is the great conundrum among scientists, is that the US practiced or celebrated the end of the millennium on Christmas or New Year's Eve, 1999, a year earlier before it was. So I guess CBS, NBC, and ABC can't count. So, but
it was an excuse to celebrate twice.
Yeah. But rest of Europe and the Western world celebrated on 2000 to 2001. I remember Queen Noor of Jordan was being interviewed on one of the nighttime shows. And he said, "What do you think of this millennium change?" And she says, "Is this anyone's millennium change?" So in order to participate, however, the key point, the most important point, is that in order to participate in the development of mathematics and science, you can't use Roman numerals. Europe needed to drop the use of Roman numerals and adopt the system of Arabic numerals and Arabic math, that is algebra. Which algebra itself means the unknown, or the sought after, which is algorithm. We've got to solve the equation.
But was the first year the year that Christ was crucified?
No.
You know, that's another issue. Just the calendar changed from 1 BC to 1 AD. There was no year 0. Christ was actually born according to as an astronomer in one of the Eastern Ivy League colleges. I forgot his name now, but he thinks he can pin it down to about 4 BC that in April that Christ was born.
So you went through the 4 years never having a birthday party.
Yeah. Well, he based it on the fact that decoding a bunch of biblical passages and historic things, that the wise men came from the east, not following an actual physical star, but following an astrological event. And that astrological event happened at the date when supposedly Christ was born. And the reason it bases on it is a conversation that loosely happened between the wise men and Herod. You know, he said, "Hey, what are you guys doing here?" He says, "Oh, we're following a star." Well, Herod could look at the sky just like anyone else, and there was no star that anyone knew about. But in ancient Israel, they had, in Jerusalem, they had forbidden the use of astrology, a wise move. But the wise men told them that it was from an Eastern astrological chart. And so they checked the chart. Herod became very alarmed, and he had all the babies less than 2 years old killed, if you believe the biblical account.
Well, my understanding is that everything before is now BCE, before Common Era. It used to be BC, used to be before Christ.
Yeah,
BCE,
that's right. It's BCE. And
now
now
the idea is you stop, sort of insulting other religions by forcing them to talk in terms of Christ.
Right. And so it's and after is CE, current era.
But somehow these Roman numeral years we're looking at just happened to come together right about the time of Christ.
No.
Has nothing to do with it.
Really? It's not similar at all. Okay. Wow.
No.
I mean, you just wrote the dates in those numbers. That's all it is.
Yeah.
Because Christianity was adopted like 3 centuries after he died by, I think, Emperor Constantine.
Yeah, that's when the Bible was written, at the Conference of Nicene or something like that.
Right. Yeah, he converted them.
Yeah.
Huh. But
Yeah,
nobody.
apparently Jesus was not a Christian. He was a Jew.
That's true.
Right. He spoke Aramaic.
Yeah.
He spoke Aramaic.
Everybody before he was born put down 47 BCE. I know Alexander the Great was 3 centuries before, but we figured that out later, didn't we? He didn't know.
Other cultures had different calendars, Ron.
Yeah.
Mm-hmm.
Yeah, of course. Yeah.
Yeah.
But ours is based on that Roman one.
Our calendar, you find it carved all over Europe, but they couldn't use it for calculations or mathematics. So
it's kind of
adopted
interesting.
the Arabic system.
Kind of interesting. What are we looking at here?
You're looking at a photograph taken by an amateur from Modern Italy.
Wow.
This is 24 3/4 hour photograph of hydrogen alpha, oxygen 3, a dual band filter, and it was taken in an 8-inch scope at f7.3. And this is a picture of the shock wave from a Wolf Riot star, WR134 in
Cygnus.
Yeah, that's in Cygnus. Yeah.
Okay.
Right.
As a matter of fact, I looked it up and it's very
Cygnus,
close to the Crescent Nebula.
Okay.
Named after 2 gentlemen, one named Wolf and one named Riot, and what's
yeah. And this is the star here.
Yeah. I think the RA the Riot should be, he was French, so it's Riot. But everybody says Wolf Riot.
Yeah.
So
every time it's French, think of Jonathan Winters as the garbage man in Beverly Hills.
A lot of letters in French that don't get pronounced. I don't understand it.
When I was in graduate school, you had to get a PhD in physics, you had to demonstrate fluency in any 2 of technical fluency in any 2 of Russian, German, or French. I did French and German, and in the French class, it was very hard to pronounce it. And the professor said, "Why is this so hard? You pronounce every syllable." And I told him that it didn't look that way to me. It looked like you pronounce the first syllable, you mumble the second, and you think the third.
That's very good.
He changed the topic as the class was roaring in laughter.
That's good.
I once asked a French teacher, here's Brigitte Bardot, Bardot. What if it was Bardiu? Oh, then it's Bardeur. All right. How about if it was DIEUX? Okay, well then it's my you. Geez, Willikers. Why even have those letters?
Well,
Right.
you know, Czechoslovakia solved some of that problem by having nothing but consonants.
Same with
Finland,
Polish, Chuck.
Finland too.
Well, I think
Yeah,
I've
my
seen-
mom always told me this stuff is easy to pronounce. So,
Yeah.
and I did fine. I did okay.
What's all the red in this picture? What was all that red?
Hydrogen alpha.
That'd be
Yeah, this is
alpha. Yeah,
background hydrogen alpha, background stuff.
yeah.
You
Yeah,
can see
that's
that
not a nebula.
there's a faint arc of
Mhm.
blue with radial streaks in it.
Yeah.
And especially here, this is obviously the bow shock, but this
Mhm.
is stuff rushing out,
That's amazing.
and the center of it all is right there.
Hey Jerry,
Yeah.
would you mind just refreshing me? What is a Wolf-Rayet star?
That's a really, well, can I jump in? That's like a really massive star that has strong winds. It's ejecting a whole lot of its outer envelope.
Okay. Okay.
And Ron, the green there, the green blue, that'd be your oxygen 3.
Okay, so this is all one star or the stuff around one star? It's not a whole nebula we're looking at.
No, this stuff is the stuff coming off the Wolf-Rayet star.
Yeah.
The red in the background is just background hydrogen alpha.
That's amazing.
And
8-inch.
it's a nebula, Ron. Nebula just means cloud.
Yeah.
Oh, and you just lifted this from the pages of Astronomy magazine? Photo of
No, I
the-
lifted this from the pages of Facebook.
Mhm.
I'm friends with several really accomplished amateur astronomers around the world who post their
Mhm.
pictures regularly.
Oh, okay, I swear I read that in your notes. Mark of the Wolf or Mark
Yeah.
of a Wolf. That's how you titled it.
Mhm.
Interesting. All right. You guys can't call up a picture like this on your scope, though, can you?
Well, Ron,
No.
it took over 24 hours of exposure.
Yeah.
Yeah,
Is that
that's
what
a
it
lot of that's a lot of wasted eyepiece time as far as I'm concerned.
Well, he probably went inside and played his guitar while this picture was being taken.
Well, Rome burned. Yeah.
Well, it'd have to be from a space telescope, then, not a one here on Earth. would never-
No.
No, that's an 8-inch.
8-inch scope.
Yeah, but 24 hours, half of that time you're on the other side. You can't even see it.
Ron, the 24 hours doesn't have to be contiguous.
Right.
Yeah.
So it's night after
Oh.
night after night, Ron.
Yeah.
Got to have a good tracker on that. You know?
And
The trackers are wow. I was thinking about tracking. That's really specific, isn't it? And
Yeah.
hairy. It's got to be.
now the
He
good
probably
thing,
turns it on and sets it up and just lets it run. And he may not be taking a photograph, but at least it's going to be tracking through the day and the night.
Yeah. So
And-
Jerry,
and-
is the Wolf-Rayet that actual golden thing in the middle?
no, that's not at
Not-
the center of the thing.
Okay.
The one that's at the center is this guy. Now
Okay.
remember, the color will be off because this is the
Yeah.
Wolf-Rayet star would be this color, red, but it's not because we're looking through very selective narrowband filters.
Yeah.
The beauty of narrowband is you can take this from downtown Manhattan, all the light pollution, because it's so narrowband, no skylight from cities and stuff tends to get in. So you can take this from heavily polluted skies. It just takes a long time.
Yeah.
to pick
And
this
you
up.
also don't need to leave your tracking mount tracking the whole time. You just
No.
have a wide enough field of view that you can then, in post-processing, register the images and crop it to the size you want.
Right. It could be maybe 100 individual subframes that were taken at different times.
Mhm.
Did I miss the words variable or Cepheid variable? Is it one of those?
No.
No,
Oh, no,
The
no.
Wolf-Rayet star.
It's
Yeah.
not. It's not sloughing off anything. Okay.
It is.
yeah,
Yeah.
it's sloughing
Yeah.
all this
Oh,
stuff off.
it's not. It's not increasing in brightness and going back and forth. That's what a variable does.
Some of them can be variable,
Yeah.
but it's a different kind of star.
This one isn't. Okay.
It
Hmm.
can be Wolf-Rayets can be variable. It depends on the conditions around the star too. If there's stuff orbiting it, moving it around it.
Well, I just learned that they're checking out the variables in other distant galaxy. Well, our galaxies that go around our orbiting galaxies, like Magellanic Cloud. They can
Well, that's
see
where they
variables,
first developed the Cepheids as standard candles.
Right.
but not inside our own galaxy.
Well,
Not
we
am-
knew the distances to the ones in our galaxy. I mean,
Oh,
Yeah,
we used
okay.
parallax.
parallax for some of those,
Right.
but the real key was seeing a whole bunch of them in the Magellanic Clouds.
Right. And those run are hundreds of thousands of light years away. But with things like the Webb, they can see individual stars and galaxies out to about, I think, 130 million light years, something like that, way out there.
What percentage of stars are variables?
Ooh.
Well, there's all kinds of variables, remember, Ron. So
Well, it just happens to be brightening or dimming. Most of them just stay the
In
same.
my opinion, most every star goes through a variable
Yeah.
stage.
Oh,
yeah,
is that
in their
right?
evolution, they go through variable stages.
Mhm.
Okay, so there's more those than there are binaries or
Yeah.
trinaries, I guess.
Yeah, it varies from star to star, Ron.
Got it. Thank
Oh, I
you.
read a very interesting speculative paper in the Astrophysical Journal about a hypothesis that our sun was once a double star based on simply the statistics of how it's easier for double stars to form than single stars with planetary systems. And the fact that they were speculating that if that double star was then, we were in a cluster and our double got thrown away, removed, that would account for several oddities of our current solar system, including the fact that we can't seem to find planet X. So,
Well,
but again,
isn't
that's a theoretical model that someone thought up. There's no
Yeah.
supportive evidence, but it is in a peer-reviewed journal.
Isn't it dynamically tough though to rip apart a binary, and much easier to have a triple that loses one or something like that?
Yes. And so that's why they said it must be very early on when we were still surrounded by cluster sisters, you might say.
Okay.
Well,
'Cause, yes,
I
They
read
have
it
to account for the star being flung out, and with two stars, you can't do it. Right?
I heard in a recent article that somebody thinks there's a star, there is a twin to our sun that comes around every 100 and so million
Oh,
years, and it
Ron.
causes the mass extinction.
Yeah, that's the internet nut Nibiru stuff.
Oh, is it? So I throw that one out. Okay,
Yeah.
got it.
Until there's real evidence, yes.
So Ron, there's also, continuous studies of what stars might have been our sisters, might have been born in the same cradle and stuff. And from velocity streaming information, it's possible that Sirius could have been a buddy,
Yeah.
Really?
And
Yeah.
most of the stars in the Big Dipper.
Yeah,
right.
there's an Ursa Major association that
Mhm.
looks like it's part of our sister star cluster.
Yeah.
One of them's coming at us, isn't it? Will join us in a few million years.
I think it's going away.
Oh, it's gone away.
There's a Gliese, I think, star, a red dwarf that is heading towards us that will someday be brightest in the sky, even though it's a dim star.
Wow.
Jerry, you missed one thought provoker among your cartoons that you sent us that said basically our solar system is rated as a 1 star.
Yeah.
Yeah, I did that. Yeah, I thought that
Maybe-
was too corny to put in there.
Well, I was all ready to comment and say, what does that make Proxima Centauri? Is that a 3-star system? They're better than us?
Well, the other thing that the joke I'd heard before was that Orion was disappointed when he got his belt. He only gave it 3 stars.
That's good too. All right, what are we looking up or down? Oh, this is Hubble.
Yeah,
That Schmidt telescope.
yeah. I put
That's
this.
cool.
This is Edwin Hubble. Now he did his work with the 100-inch on Mount Wilson. This is the 48-inch Schmidt camera, which is a telescope you cannot look through. He's actually looking through a guide scope or a finder scope on the side of it. It has a 6-foot diameter spherical mirror. It has a 48-inch aperture up here, and it has a curved focal plane. So the the photographic plates are like 10 by 10 inch, but they have to be conformed to the sphere that the focal plane is. So this was the first wide field camera to be
Do
used.
they have a cartridge or something in there so they can take multiple pictures without taking telescope apart?
Oh, no, they have trap doors. You can see some little squares up here and things. The focal plane where the things go is up at this end. And you put one plate in, you expose it, and then you take that one plate out, and then you move on to the next one. They had digital cameras, and even cameras with plates in them were yet in the future. This was at about 1950 or something, or the 40s when it was built.
Oh, okay.
This was one of two similar telescopes that was used for the Palomar, what they call the Palomar survey.
Yeah.
So this is in Mount Wilson.
No,
This
this
one's
is
at
Mount
Palomar.
Palomar.
That's a Palomar run. Yeah.
Ah, okay, got it.
Even though he did his work on the 100-inch at Mount Wilson. But this
That's
is about his work. And this is, he looked and he saw that he started measuring redshifts spectroscopically. And he found that the faster something was moving away from us, or the farther away it was, the more redshifted the thing was, which meant that it was moving away from us. And so he made this velocity distance curve. And this became the Hubble constant. And what we're about to discuss is it may not be constant, but that's
A Hubble
yet to be seen.
parameter is the current term, I think.
Right. So these galaxies were farther away from us, but they were not very far away from us when he did this work. This was in the 1920s.
Yeah, the constant's basically the slope of that curve.
Yes.
Like, yeah,
They do best square, at least square fit or something to it.
yeah.
So
And
now there are
there's no
several
scale
ways.
on it. There's no scale set on it.
Yeah.
So you'd say it's a couple of miles.
That's right.
So the bottom line is there's some tension in the astronomical community about Hubble's constant. Some
Yes,
tension.
these are publication year for measurements of the Hubble constant.
Hmm.
There are several ways to measure it. There's measuring the lambda from the what is that, the
Cosmological constant?
thing? Yeah, the cosmological constant, but this is the cosmic.
No, lambda cold dark matter.
Yeah, that's it. Thank you.
Mhm.
I'm not completely over the brain part of so, and then there's two ways to measure it, and these are the two ways shown down here. The distance ladder is what he used, and what?
Got something from the peanut
Hang on a
gallery.
second, something's going on with the dog downstairs.
Uh-oh. Chuck, you want to take over? What are we looking at?
These were early, some of them were earlier methods, the distance ladder of measuring the constant. You can see there's a huge error bar at first, although these are publication year 2000. So there were even worse error bars on it way back when. You can see how with the blue squares, they're kind of narrowing down the error bars. And then with WMAP, that's using the cosmic microwave background. And those, you can see the error bars are getting smaller and smaller, but they're diverging. They don't overlap. So that's the tension.
Yeah.
You're getting two different methods of measuring the Hubble parameter, and you get two different answers, essentially.
Right,
and
right.
there are 3 or 4 new ways of estimating it that Jerry's probably going to talk about that are kind of resolving that tension.
Okay.
Or adding to it.
Yeah. Well,
yeah, and this is a more recent update of techniques, you might say. The
controversy.
Yeah, so here we have prediction from the Planck collaboration in 2020. Now, these are not years. These are values of the Hubble constant, kilometers per second per megaparsec. So the theoretical one is right here, from the standard model of cosmology. This is the golden standard. It's what everybody's trying to get to. This is a new technique looking at a region of the asymptotic giant branch stars. And that is it within the error bars here of agreeing with the theoretical limit or theoretically derived value. This is from the tip of the red giant branch stars here, gives a value that's too high. This is from Cepheids. Let's see, from Cepheids, the web data. And that gives a value that's higher yet, 72. And this one is a Hubble and Webb data from Adam Rees, and it gives the highest value yet. It has the smallest measurement error bars. So, and Adam is sticking to this. He doesn't modify it. They're trying to find, the idea is that there is a systematic error somewhere in it.
And the Rees measurement seems to be the outlier. So they're thinking there's some systematic error in that, even though he's sticking to that.
Yeah, but he's got a Nobel Prize, Chuck.
Yeah.
And he's sticking with it.
Yeah.
So,
does the problem arise with the more distant galaxies, or are we having trouble with some of the
yes,
nearby?
it's basically a dispute between near stuff and far stuff.
Ah,
So either it's changing over there's two possibilities. Either the value is not constant and it's changing over time, or there's a systematic error in it. And the consensus is that there's a systematic error in the measurement somehow.
But it is changing over time still. There is still the dark energy problem.
Yeah.
But this is just resolving what's going wrong, that these H0, H naught, this Hubble constant, if you take it the way Hubble was thinking about it, what the base value is for our time and our region of space.
So it might be a polynomial rather than just a straight line.
Yeah.
Yeah.
Yeah, we don't know how it varies. And it
Right.
does seem to be a polynomial because it acts as though if you have twice as much space, you have twice as much propulsive energy.
huh. Can I ask one of my silly, sick questions? Do you suppose the Webb will probably, if it keeps looking even deeper than these 5 globs that it says were created within the last 200, 300, or 400 million years after the Big Bang, will the light waves go away completely and they go down into the radio spectrum, and the only way we can see them is radio telescope?
They go down to the microwave section. That's why it's called the microwave background.
It's basically the surface of the fireball of the Big Bang. So it's as
Right.
far back
From
as you can
300.
look. But it's
So-
when the universe became transparent. So that's already about 300,000 years after the Big Bang.
Yeah, perfect. Yeah.
But are the radio telescopes picking up globs that an optical or even an infrared couldn't see because they're in radio waves, and it represents the galaxy that is so far away that it's gone into the radio
No,
spectrum?
there were no galaxies that far back.
Right.
At the microwave and radio frequencies, there were no galaxies.
So everything's still on the light spectrum or the infrared. Interesting. Okay. And those distant galaxies are too far away to see a variable star in any of the galaxies. I
So
would
far.
assume.
Yes. Yeah.
So you can't judge them that way. You only have the infrared.
Well, we can look at them with what's that lensing?
Yeah. Gravitational
Gravitational
lensing.
Lensing.
And part of the problem, they think, with this Cepheids, you'll see they're the ones that are kind of causing the controversy, is that you have to, when you're looking farther and farther away, and you think you're seeing an individual Cepheid, you're also seeing a bunch of other stars in your field of view. And so that can bias your brightness measurements that you get for the Cepheid. And especially if there are a couple of Cepheids within that field of view, you can kind of get an overlap of those things. So in the discussion of in the articles I've read about this, they're saying that may be part of the problem. And the Webb has much better resolution, so it's able to pick out the individual Cepheids better. And that's what has pulled that measurement down from 73 to the 72. And that if you consider that that might be part of the systematic problem, it could pull it down even more to the lower end of that yellow line that says Cepheids.
Right.
And then you're starting to resolve the Hubble tension.
Now, when you're looking that far back in space and time, you're looking at something that's moving away from us very rapidly, and time is dilated for those guys. So if you do see a Cepheid variable, the time dilation will give you an incorrect reading of the frequency of it because the time is slowed down. So it's very difficult to calibrate the frequency of the Cepheids.
Yeah.
In other words, they do it slower because they're farther away.
Because they're moving faster because they're farther away.
But
Right,
what
they
we
have slower clocks, Ron.
Right.
okay, but I mean, if we're seeing them dim and brighten, it'll be slower than if they were in the galaxy next door.
Yes, a longer period
Yeah.
for the same brightness.
What was the name of that woman that did so many of the calculations? Henrietta something?
Henrietta Leavitt?
Levitt?
Did she start that after Hubble discovered his variable
No.
thing that he wrote
Oh,
on the
no, no.
He
She's
used her
responsible
data.
for his discovery.
Really?
Yes.
She was before him, and she did a bunch, didn't she?
Yeah.
Yeah.
Mhm.
Wow.
Yeah, one of the computers.
I read that the New York Times just recently gave her a proper obituary, just recently.
Yeah. Well, it's now called the Levitt Law.
Yeah.
The
Levitt, that's her last name. I got it.
Mhm.
Ladies, come a long way, baby.
I worked with a colleague at Santa Barbara Research Center who in her graduate school, she worked at the Cavendish Lab in England.
Uh-huh.
And she worked at what was it, the George Washington University in St. Louis. And
Mhm.
then she was at the Santa Barbara Research Center, yeah, on the same teams I was on. And she was one sharp cookie.
Yeah. Yeah.
She described in detail how difficult it was for her as a woman dealing with scientifically based male organizations.
Yeah.
It sounds horrible.
Yeah.
There's a good
Definitely have got a short shrift in the sciences.
there's a good book out called The Last Stargazers by a lady astronomer that was when I went to Tucson for that ASP award, she also got an award as an up and coming PhD.
Uh-huh.
And she describes all the things she had to go through. Like she was I think it was down at Cerro Tololo, but it might have been at the Keck Telescope in Hawaii, but she was the lead person that night. And there was a younger PhD male that showed up and said, well, who's the director? And she said, that's me. And he said, no. I mean, who's the director tonight running the telescope? She's like, well, that's me.
Yeah.
And you're dismissed.
Yeah, it was just, anyway, she says we're really losing a lot because people don't actually go out and look at the sky because of light pollution.
Mhm.
And they all they see is data, and also describing the problem she had as a woman trying to integrate into the male dominated astronomy community.
Yeah. Vera Rubin also had to live through a lot of that baloney.
Yeah.
Well, didn't Carl Sagan make it a woman that was the star of his book, Contact, Jodie Foster?
Yeah.
I think that was Hollywood. I don't know if that was
You're right.
he wrote her in. Anyway, the bottom line for this tension is that the three methods disagree. That the three methods disagree is not telling us about fundamental physics. It's telling us there's some systematic error in one or more of the distance measurements.
Mhm.
So getting that straightened out is the real resolution to the tension.
And the nice thing about these red giant branch stars is you can pick them out of the background stars a little better.
Yes.
And Betelgeuse is one of them. Does it weigh in on any of these calculations?
No, it's much
No.
too close.
Mhm.
It's about to exit stage left anyway.
Yeah.
There
So
it
this
is.
is a very dramatic shot of the Hubble telescope during final assembly in what we call a high bay clean room.
Mhm.
It's got a tall ceiling.
Wow.
Very impressive.
Mhm.
Real gold on the level of that mirror, isn't it?
It is gold-plated nickel, as I understand.
Oh,
I think it was beryllium.
It
Beryllium,
could be
you're
beryllium.
right.
We use beryllium for all of our optics, gold plated or silver plated beryllium, and it could be beryllium. But
I think it's less massive that way, and it also has better thermal characteristics.
well, it's not only that it has better thermal properties, but they made the entire spacecraft, in our cases, out of beryllium, so it matched exactly the thermal properties of all its surrounds.
Whatever it did in
Yeah.
unison.
Now, beryllium is a very toxic metal because it's particulate dust forms a beryllium oxide, which if you breathe, it gives you a version of black lung almost instantly called berylliosis. So there were only 2 places in the North American continent that would machine beryllium, and they really did a land office business.
I think they started out, well, they may not have started out that way, but those companies may have been responsible for some of the, it's sort of a hype thing, but golf clubs that had beryllium.
Oh,
yeah.
But do the 2 elements get combined like a compound?
No.
beryllium is just one element.
Okay,
And
they're just together.
You make your thing out of beryllium like we make our telescope things out of glass. And then we coat them with aluminum and they coat them with gold.
Yeah.
And somehow light reflects off what, both of them or one
No,
of them?
It just reflects off the gold. The gold's the only thing the light sees.
Right. It's element 3, Ron.
I know that. Okay. Oh,
Yeah,
beryllium?
it's also hexagonal close packed. We worked with that at Arizona.
Element 3 is lithium, isn't it?
I'm
Beryllium.
sorry. Yes, you're right.
I was right.
Yeah, beryllium.
Yeah,
You're right.
I'm just along for the ride here, guys.
Good one.
Yeah. So it must be number 4.
Yeah.
Yep.
We had an
Okay.
engineer at work that used to write all kinds of stuff on his blackboard, and this was in the days of the Polaroid cameras. Then he used to take a picture of it. And if you came into a meeting and you said, Fritz, you said da 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 da, and he said, well, do you have a picture of me saying that?
All right, this is one of the probes on the way to where Jupiter's moon.
This is the European Space Agency's JUICE, Jupiter probe.
That's
It's
our
going to
planet on
study
the left.
Jupiter and its 4 biggest moons.
And there it is going around us, right?
Yep,
It's
they
going
use that
past
for
us.
gravity assist.
Yeah.
Wow. And it's also
doing-
going to go to Venus?
It's first it goes by the moon Earth system, which it did a few days ago, and these are pictures. And then it's going to fly by Venus in August of 2025, a year from now.
Oh, it's going to go inward in the solar system and that'll flip it back outward.
Yep,
Wow.
there it's going by the moon.
Mhm.
We can see, what is it, Petradia?
Yeah, there's the moon.
I'm tongue
Like
tied.
Clavius. Looks like Clavius, huh?
No, this is Petavius.
Petavius.
Petavius, yeah. And then
What? Clavius is my favorite, I think, because of 2001 Space Odyssey.
no, Clavius, because of that movie, Clavius is one of my favorite.
Mhm.
Yeah.
But it's not shown in this picture.
No.
This is the wrong, Clavius would be way up to the upper left.
Tom always shows me that out at Westmont when we get the giant moon.
Mhm.
We're starting to pollute the atmosphere, well, whatever it's around the moon with our pollution. There's how many things are orbiting our moon now?
Well,
Gonna-
this is not orbiting, this is zipping by.
That's
But
true.
it turns
you're right.
out that the moon now has an atmosphere, which is 100% rocket exhaust from the retro rockets of everything that's landed near there.
Oh, for crying out loud.
Well, they also have what's called an exosphere, a really thin atmosphere that's caused by the bombardment of micrometeorites on there.
Yeah.
And when the Terminator passes over an area, you get a sudden, going from minus 200 to plus 200 Fahrenheit on the rocks, and they flake off little bits, and then static electricity suspends them. So there's like a little cloud that moves along with the Terminator.
Mhm.
I assume in the word JUICE, the JU stands for Jupiter. I wonder what the rest of the acronym is.
Icy Moons Explorer or something like that.
Got it.
This must be a hard thing to see on your set.
Yeah.
So it shows the
Can you
launch here from, let's see, where's the Earth? Venus, there's Earth right there. Here's the Earth lunar flyby. This is Earth flyby 2. And then this is launch from Earth. So it goes there, there. Then it goes, this is the Venus flyby right there. Venus is the gold dot, which you can't see. And then it flings it out on its final leg to Jupiter. So it's going to land there, Earth flyby arrival at Jupiter in July 2031 down here. And then it's going to end in September 2035 when it is purposely, oh, that's the other one. Never mind that.
Europa Clipper?
Yeah.
Yeah, I got what's this one? What's Juice gonna do? Just
Juice. They're gonna do pretty much the same thing.
Oh, zeroing on Europa.
It's going, the Juice is going to look at all 4 moons, and Europa Clipper is going to look at all 4 moons too, but it's going to pay special attention. It's going to come within 16 feet or something, 16 miles of the, not feet, miles of the surface of Europa.
Okay, and it's NASA. That's ours.
Yeah, this is Juice's European Space Agency.
And they're all
AEM is
collaborative
partners
these
with
days.
NASA.
They're all
So-
collaborative these days. There are
Yeah.
instruments from all kinds of
Yeah,
agencies.
it's just cost effective to do that.
And they're
But
talking about crashing it into Ganymede, which surprises me because they're going to have to really decontaminate it.
Yeah.
Oh,
So
That's
this is
not
a picture of the Europa Clipper. This is called the vault on the Clipper because they're making it radiation hard, which means that all the electronics and everything, except for the wires going out to the antennas, is all locked in here so that the computer doesn't get corrupted, because it's going to spend a lot of time in the radiation field around Jupiter, which is very destructive of solid state electronics.
Well, it looks like the
Would
cameras.
it be bad?
What's that?
It looks like the cameras are not in the vault.
No, the cameras can't be in, and the wires coming out to the antennas can't be in, but all the electronics is inside.
Well, the cameras have solid state sensors, right?
They do. And there are ways that you can make solid state sensors a bit more radiation hard by using total internal reflection and having the electronic gate located far away from the actual entrance aperture of the light.
in other words, in the old days when we had film, that film would be totally ruined by the radiation.
By the way, I'm co-author on that patent. So
Are you really?
yeah, but the
Okay.
The vault is probably titanium.
the what?
The vault,
The vault?
Probably made
the
it.
vault structure is probably titanium. I know that's what they used on Juno.
Yeah,
Yeah,
that's what I was asking if it was lead, because that'll be a lot of weight.
Yeah.
Huh. And so it's going to shoot radio waves down into
oh
Europa.
yeah, it's the walls are made of 1/3 inch thick sheets of aluminum zinc alloy.
Okay.
Works for me.
Yeah, Tim,
Yeah.
they scrapped your idea of using unobtainium, by the way.
And they scrapped using the famous mineral leverite. When you're prospecting and you find it, you leave it right where you found it because it's worth it.
I love it. I love it.
So let's see, go back here. The Juice is now passing by the Earth system. The Europa will be launched in October of 2024, so about a month and a half away. It'll do a Mars flyby in 2025, Earth flyby in 2026, Jupiter orbit insertion 2030, first year Europa flyby of spring 2031, and the possible end of the mission with a Ganymede impact in September 2034. That's when Congress is estimated to lose interest in the thing, and so the funding stops. So they pull the plug.
Wow. And they're saving all this money on rocket fuel by letting the planet slingshot it by, huh?
Yep.
Over and over.
Now this one
Are you
is an interesting thing. It's a photograph, but it's discovered in 1939 by Rebecca Jones and Richard M. Emberson.
We're seeing a star map, Jerry.
Yeah.
It is the Headphone Nebula.
Right.
I've located it here. It's in
Oh, okay.
and Lynx, as you can see, is near Gemini. This is the morning sky at
Right.
5 a.m. Tomorrow. So
Yeah.
that won't be any different today.
Right.
Jupiter's way
So
up there.
I was going to say Jerry Castor and Pollux came up around 4 this morning.
Okay,
Oh,
so that's
okay.
about right. This is about 5 o'clock.
Mhm.
And it's a very interesting thing. This is a photograph of it, but it's a
Wow.
long photograph. If you do a shorter photograph like we would do in ours, you only see this ring and these two muffs here. This thing
Wow.
is completely gone. So it does look like a pair of headphones.
Huh.
So it's how long have we had headphones? I guess they had them in the 30s, didn't they?
Now
Well,
this
when the
thing,
telephone came around,
Yeah, that's true. You're
well,
right.
this one doesn't have an NGC number or any other thing that's easy, makes it easy to locate.
Messier, no Messier objects.
Oh,
Okay,
no.
yeah. No, it's definitely not a Messier object. That central star in there is 18th magnitude.
Yeah.
Oh,
So it's a challenge to get to see this and do the photograph of it.
oh, so it's a
It's
planetary. Okay.
Well, anyway. Oh yeah, this is one real quick thing. This is the planet formerly known as George, and we had claimed that it should be called Doug a few sessions ago. But it turns out that for about 30 years after its discovery, Herschel named it after King George III, the one of USA Revolutionary fame. And so he named it George. And so that was its, before it was named, taken over by the IAU and named Uranus.
Mhm.
So if we want an alternate name, we need to use George, because that's
George.
its original name.
Okay. All right.
Would that have been the
Good job,
same King?
George is in.
Is that the same King George that our Revolutionary War fought
Same
against?
guy.
I'll be damned. Well, Uranus or Uranus is a god, isn't it?
Yes.
Mhm.
How do they pronounce it?
They're all
Uranos.
dead.
What?
Uranos.
Uranus?
Uranos. Yeah.
Urano.
Okay, well, that has no
long
connotation.
view, huh?
That's neat.
Doesn't embarrass me. Planet George or Planet Doug or God bless you all. I guess that is it for the hour. I learned a lot. And I was right on one point. Doggone.
Right.
Put that on my scoreboard over here, and we will meet for number 184 next week if you're up to it, gentlemen.
You
Yep.
beat
Take
me, Ron. You beat me by one.
Take your win, Ronnie.
Real quickly before we go, Chuck, outreach, anything happening before the meeting? This
September, August 30th. So this Friday, Las Flores Ranch Park Star Party up by Santa Maria, fairly
Okay.
dark site. And then 31st of August, Saturday is Kachuma Lake.
Okay, bring your black cats. They need an outing. We'll see. Take care of
And
yourselves and happy
for you-
August.
For you Heinlein fans, periodically on Chuck's shoulder was his puppet master.
Yeah.
Welcome
Yeah.
to Sesame Street.
Yeah.
All right.
It's almost snack time. Yeah.
That's it for
Bye.
the